Polynomials, summative review. Now we're up to the objective on solving polynomials. Usually this is going to be objective 3 on your test. So we're going to take a look at this. And to solve something means to set it equal to 0. Solving means to find the x-intercepts, roots, zeros, solutions. Quadratic formula can be used when we get it down to a quadratic or something that's in quadratic form. But let's not jump to that too fast. Remember factoring? That can be really nice too. Over here, we have 2 and 250. I can take out a 2. M squared m to the 5th. I can take out an m squared. That leaves me with 1 minus 125m, and this should be a hint, cubed, equals 0. My, oh my, oh my, I got a difference of cubes. Remember, we're going to use SOAP. Same opposite, always positive. I still have my 2m squared out front, but now I have to factor my difference of cubes. So it's cube root minus cube root. Then I square the first, oops, multiply these two, and then square the last. And that's not, it's squared on the outside. I just couldn't quite fit it in there. Now, I set each factor equal to 0. So, this one tells me that m is equal to 0 twice. So I've got a multiplicity of 2 because it's squared. Here, m is equal to 1/5 when I set 1 minus 5m equal to 0. The problem is this guy, he's a trinomial that's not factorable. So I have to use the quadratic formula. But I'm going to rewrite him as 25m squared plus 5m plus 1. I can do that because commutative property. So m is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Simplifying this, I've got negative 5 plus or minus the square root. 25 minus 100 is negative 75 over 50. Great, got to keep going. So this is going to be negative 5 plus or minus, okay, 75 is 25 times 3, and then I have that negative 1 there. So that's what I'm thinking about. So I've got 5i root 3, the 3 has to stay underneath, and then I have 50. I can simplify this because 5 will go into 50 10 times, go into each one of these once. Negative 1 plus or minus I root 3 all over 10. So this crazy polynomial here, it's to a 5th power, means I should have, remember, 5 solutions. So I'm going to have m is equal to 1/5. That's one solution. Then I have 0, and here I'm going to put multiplicity of 2. And then I have negative 1 plus or minus I root 3 over 10. So there's 1, 2, 3, 4, 5 solutions. I did it. See? Now this one you had to use greatest common factor factoring, difference of cubes, and then the quadratic formula. Lots of stuff from prior knowledge. Next up, this guy. Let's factor him by grouping. Oh, wait, I can't group yet. That's an equals. I've got to get everything, I've got to set the equation equal to 0. So I've got x cubed plus x squared minus 2x minus 2 equals 0. Now I can group. I'm going to group the first two. I'm going to group the last two, and notice I've got a minus here, so I have to change the sign on the inside. Greatest common factor, x squared, then I've got x plus 1. Minus greatest common factor is 2, x plus 1. Now I've got x squared minus 2 times x plus 1. I factored this one by grouping. X squared is equal to 2. X is equal to plus or minus root 2. Remember I said each factor equal to 0. If x plus 1 is equal to 0, then x is equal to negative 1. Get that negative in there. So x is equal to negative 1, and then plus or minus square root of 2. It's a cubic. I have 3 solutions. I've got 3 solutions. All right? If you want to, you can pause the video and take a look. Again, greatest common factor, difference of cubes, and quadratic formula to get all my solutions here. This one was factor by grouping. Next up is this crazy thing. 16x to the 4th minus 91 is equal to 0. I don't have any other x's, so I can just do 16x to the 4th is equal to 91. Add 91 to both sides. Divide everybody by 16. X to the 4th is equal to 91 over 16. Now, if I take the 4th root, I'm taking the 4th root, so I've got to consider positive and negative. X will be equal to plus or minus the 4th root of 91 over 16. Ooh, well, 91 over 16. 91 is kind of like that crazy prime number, so I can't really do a whole lot with him. But I can get rid of the 16 in the denominator. This is equal to plus or minus the 4th root of 91 over 2. And it's a multiplicity of 4, or basically 2. Okay? It does it twice at the positive and twice at the negative. X is equal to plus or minus the 4th root of 91 over 2. Here, I've got another one. Now this one I can go ahead and group easily. And I don't need to add any minuses. So I'm going to get x squared times x minus 3 plus 3 x squared minus 3. Again, greatest common factor. You should be able to factor now. Now we have x squared plus 3 times x minus 3 is equal to 0. X squared plus 3 equals 0. X squared is equal to negative 3. X is equal to, and this is what's important, plus or minus I root 3. Don't tell me no solution there. X minus 3 equals 0. X equals 3. So now I have 3, and then plus or minus I root 3 is my other answer. So far, so good. Oh, now this one, it's one of those technologically enhanced things where you have multiple choice, but you got to pick all the right multiple choices. That's okay, you can do this. Again, notice this is nothing more than grouping. So now I'm going to take out a 2x squared, and that leaves me with x plus 3. Now here, don't forget x plus 3, I can take out a 1. Put that 1 out front so that you see it, right? So that you don't make the mistake of making it a 0. Now you have 2x squared plus 1 times x plus 3 equals 0. x plus 3 equals 0, x is just equal to negative 3. I can look around here and say, winner, winner, chicken dinner. Got it. Here, I have to work a little harder. 2x squared plus 1 is equal to 0. 2x squared is equal to negative 1. X squared is equal to negative 1/2. So now x is going to be equal to plus or minus the square root of negative 1/2. First off, I'm going to get to bring the I out. So plus or minus I, and the square root of 1 is 1, so that's okay there. I don't have this guy, but wait. I have to rationalize the denominator, which means I have to use the multiplicative identity, multiply by a form of 1, and now I have plus or minus I root 2 all over 2. So now I've got negative I root 2 over 2, positive I root 2 over 2. Okay, that's it. That is solving polynomials by factoring, quadratic formula, etc. Got it? Great.